Hey, hi everyone. Good evening. Good evening. Welcome. Join me in as we discuss the continuation of numbers, some of the impactful and important topics. All right. So that's what we are doing as a part of Cat Ninja. So we are seeing some of the concepts from DILR because with the paucity of time, we may not be able to do all for Cat 21. But yes, so we will try and do at least the most impactful ones till we come close to the exam. And yeah, here we are. So we are doing quant again. So we've started numbers some time back, but these concepts are a little isolated. So I will talk about one of the important concepts today, which is the Euler's number. Give me a quick confirmation that audio, videos are fine. So all good out here. So somebody who has joined in, get me the confirmation that things are good. Yeah. Yeah. Hi, Afufra. Hello. Hi, Maurya. Hello. 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 Great. All right. So by the time others join in, we'll continue our discussion. Let's quickly put it into perspective. So the Euler's number is pretty important. All good, right? Okay, good. All right. So let me introduce quickly myself, for those who are there. So just in case you are not aware, so what we are doing, what am I doing? So here I am. So I'm Belvi Srinivas. I've worked with various test prep industries in the past. That's for about the last 14 years, that's since 2007. So over the period of time, yes, I did develop some expertise as to how to counsel the students to reach their goals, and also like so how we can mentor them to learn concepts like concepts from QA, DI, and LR. That's a bit of my background out there. Yeah, yes, I do counseling also pretty well, so pretty detailed, so you can just interface with me on this particular ID for a brief counseling. So if it is a very short, that's fine. Otherwise, so elaborative counseling, we have to do it in a different way, right? Okay, so that's pretty much. So let's get started with the Euler's number. All of you sit with your pen, maybe sit with your book. That might help each one of us. So keep your book ready, keep your pen ready, give some confirmation that yes, you are kind of sitting with your book and pen. Yeah, all right, Kushi. Thanks for confirmation, buddy. All right. Good evening, Prashant. Good evening. Good evening. So give a quick confirmation that you are ready with your tools. It's very important that I don't want any passive onlookers. Yeah. Sarthak, is it long time? I think you were there yesterday, day before. No, you were not there. You're saying that it's long time. You didn't see me. Yeah. Weren't you there yesterday, day before? I think I read your name in last yesterday or day before, whatever. I'm not sure. It appears pretty fresh in my mind. Why you're saying long time? I didn't disappear anywhere. You disappeared by any chance? So let me know. Yeah. Great. Any which ways. All right. Hmm. Hmm. Good. Let's start. Let's start this concept. Let's start this concept. Very interesting concept out here. Yeah. Let's see this. So how we can work through this particular concept. Okay, so what is this Euler's number that we are talking about? So what is this Euler's number? Euler's number, first of all, the definition of Euler's number is number of numbers co-prime to the given number and less than that number. Two conditions. Listen to this very, very carefully because the applications are very, very beautiful. You need to understand this concept. Yeah, I will do half the applications because I have to teach you factors also before I do the complete application. But learn these half applications very, very. I mean, there are half a dozen, more than half a dozen questions of this particular concepts in the past. That is from 1992 till now. But if you are looking at IIFT, ZAT, etc., you get plenty of questions during that particular season. So here we go. I mean, not just season means I'm talking about last 20 years of history. You find a lot of good questions presented from this particular number. Somebody has to know about the Euler's numbers to do those questions? No. But if they don't know, it will take longer time. That's it. That's where we sometimes we bring certain technicalities because with those technicalities, it becomes a lot more easier to understand, a lot more easier to solve the question. Without that, also we can solve, but it is through first principles will take definitely much, much longer time. Fair enough. Let's take a look at this. So therefore, how do we work through this particular concept? Let's try and understand this, how this works. Say, for example, what is the definition? 2 points. Euler's number has two conditions. Condition number one, number of count of numbers. You have to count. It's a count. Well, Euler's number is a count of numbers. Okay, so then what? Less than the given number, less than the given number of numbers, less than the given number. Point number three. All right, that's how you kind of understand and present it in your mind. And co-prime. All right, co-prime to the given number, less than the given number, less than the given number, and co-prime to the given number, co-prime to the given number. Let's understand this. What are these three things mean? Right, let's understand first one. You leave it, counting we'll do at later stage. First let's understand this, what we meant here. If I say 15, I want the Euler's number for 15. Technically, if you studied about a little bit of algebra there, Euler's number is generally represented by 5. 5 of 15 means I'm trying to say that give me Euler's number for 15 represented by 5. If you are reading some books, etc., it is generally represented by 5 of 15. So therefore, you kind of manage the same thing, 5 of 15. Okay, what is this 5 of 15? Euler's number for 15. We will write the answer. I have to write the count here. These many numbers is the answer to this particular question. What does it mean? So this is the sample size. 1, 2, 3, 4, 5, 6. Like this, up to 15 I will write. Up to 15 I would write. Listen carefully here, because once you understand, you will see the applications, how it becomes level 0, level 1 questions. Right. So up 15 numbers I have, because I want the Euler's number for 15. Therefore, I wrote the set from 1 to 15. Now I said that, hey, the numbers should be co-prime to this particular 15. Is 1 co-prime? Yes. Is 1 co-prime to 15? I'm checking with this. I'm checking 15 on one side. HCF. What do you mean by co-prime? HCF of 15, comma, X should be 1. Okay, if I in place of X, if I write 1, in place of X, if I write 1, will the HCF be 1? Yes, therefore 1 is shortlisted. In place of X, if I write 2, the HCF of 15 and 2, will it become 1? Yes, shortlisted. In place of this, if I write 3 here, 15, comma 3, will the HCF be 1? No, HCF will become 3. Therefore, 3 is discarded. All right. Similarly, when I look at 4, when I write 4 here, 15, comma 4, will HCF be 1? Yes, HCF is going to be 1. 4 is included. What if I write 5 here? The HCF becomes 5. Therefore, it is discarded. Okay, 5 is out. What about 6? 6 is out, because if I write in place of X, if I write 6 here, if I write 6, the HCF becomes 3, right? So because I said that, hey, I want numbers to be co-prime. I wrote the numbers less than. We said that write them less than the given number. Less than given number. In fact, 15 is also not required. That's okay. Up to 14 I can write there. That's not a worry. So, but then I'm writing now all at this 6. Solid 6 is out. 7 is in, likewise 8 is in, 9 is out, because in place of X, if I write 9 here, or if I present 9 here, then the HCF would become 3 there, therefore 9 is also out. 10 is also out, because if I write 10 here, the HCF would become 5, therefore 10 is also out. 11 is in, 12 is out, because the HCF would become 3, 13 is in, 14 is in, 15 is out. 15 is out, right? The last number 15 is going to be out. Fair enough. Therefore, how many numbers are co-prime to 15 and less than 15? I will count. One number, second number, third number, fourth number, fifth number, sixth number, seventh number, eighth number. I am writing this count here. I am saying that, okay, count. I have to write a count here. Therefore, 5 of 15 is 8. What I'm trying to say, 8 numbers are less than 15 and they are also co-prime to 15. Okay, are you clear with the definition, my friends? Are you clear with the definition? Are you clear with the definition? 5 of 15 is 8. Is that point clear? Is that point clear to everyone here? Is that point clear? Is the point clear? 3 conditions we have put. Count. Counting is large. Counting is large. First, what I should do? What is my sample space? My sample space is less than the given number. Less than or equal to the given number. And what I'm looking for? I'm looking for co-prime to the given number. What is given number? Given number was 15. So I put 15 here. Now I'm using my sample space. All these will be one by one. They will stand in the place of X there. And I'm checking whether the HCF is becoming 1 or not. All right, HCF is becoming 1 or not. This is what, okay, now should we be doing like this, which means when I ask that, hey, write the co-prime, write the Euler's number for 240, does it mean I will write till 240? No, we don't write. First we need to visualize and understand. After that we will evolve and we will find out that what does it mean therefore, all right? Now what is the meaning of this? Let's try and understand this in multiple ways, the same scenario, right? So that is the point out here. Okay, so you tell me what is the Euler's number for 21. Try it out, everybody try it out and let me know the Euler's number for 21. Find out the Euler's number for 21 using whichever the method. 21 is a small number, no big deal about it. No big deal. So whatever the method at least I taught you, go by that and tell me the Euler's number for 21. Put it in the chat. What is the Euler's number for 21? It's a count. number of numbers less than 21 and equal to less than 21 and co-prime to 21. First, let's find how to find the Euler's number. Then we will figure out that, okay, what is the application of this? What does it mean to us? Where all we can use it, right? Where all we can use it? Because a lot of times we learn this, but we don't apply this. That's where the problem starts. We should know and then we should apply, right? Okay. Very good. Very good. See, all right. Now let me explain this in a different way. Now let me explain this in a different way. Right. So what I'll do, 15 was a composite number, same thing I'm explaining, my friends. I will take 15, then I will come to 21 so that I can teach the second way of looking at this stuff. Right. Okay. 15. I said that any composite number, in the previous lecture I mentioned, any composite number, resolve it into primes. Okay. This is 3 raised to power 1, which is 5 raised to power 1, which means when I say that co-primes to 15 means all multiples of 3 should be removed, all multiples of 5 should be removed, rest of them will be co-primes to each other. That's the whole point we are trying to say. Fair enough. So therefore, how do you represent this? If you want to represent using a Venn diagram, this is another style, just a style. So will we be doing any of this? No. Once we understand the concept, neither will be writing this, nor we will be writing this Venn diagram. Nothing will be doing, but we need to understand and visualize it so that we'll understand where all I can apply this. If I don't show you all this, you will not understand the application in the exam. Suddenly question comes and you will not know what to apply in this particular question, because knowing and applying are two different things. For that, you have to understand the nuts and bolts of this. Fair enough. Okay, there are 15 numbers here, 1 to 15. Okay, what are the numbers here? 1 is there, 2 is there, 3 is there, 4 is there. Like this, up to 15 is there. There are 15 numbers. Count, I'm writing here, mu is equal to 15. Total count is 15. Okay, all multiples of 3s I will write here. All multiples of 5s I will write here. You may wonder, where are these 3s and 5s coming here? Because if the number has to be a co-prime to 15, I have to remove the multiples of 3s and I have to remove the multiples of 5s, which means which numbers I am interested in? None. I'm interested in the region of none. What all numbers you write here, I will be interested in this. Okay. Now I will remove the multiples of 3s in the first 15 natural numbers. Multiples of 3 means every third number. 3 comes here, right? 3 comes here, 6 comes here, 9 comes here, 12 comes here, and 15 comes here. 15 comes there. I am removing all multiples of 3s. Multiples of 3s up to 15 means what? 3 1s are 3 2s are 3 3s are 3 4 the 3 5s are, right? Therefore I wrote that 15 inside there. Fair enough. Okay, what about the multiples of 5? I will write here 5 comes here, 10 comes here, and 15 comes here. Okay, therefore what are the numbers left, man? The numbers left is 1 is here, 2 is here, 3 is here, 4 will be here, 5 is here, 6 is here, 7 is going to be here, 8 is going to be here, 9 is already here, 10 is already here, therefore 11 is going to be here, right? 12 is already here, therefore 13 is going to be here, 14 is going to be here, but 15 is here. Fair enough. This is using the set theory, right? Using the set theory. Count, did I get the same numbers? Yeah, 1 is here and 1 is here. There is a 2 here, there is a 2 here. There is a 4 here and there is a 4 here. You wrote 7, you wrote 7. You wrote 8 and there is a 8. There is 11, there is 11. There is a 13, there is a 13. There is a 14, there is a 14. Same things out there. Fair enough. This is another way of looking at it, which means you could say that, hey, I took 15. I found out how many numbers are multiples of 3s. You are looking at number of numbers multiples of 3s. Okay, therefore you said that 5 numbers. How many numbers are multiples of 5s? You said 15 divided by 5. Number of numbers which are multiples of 5 or 3. Number of numbers which are multiples of 3 as well as 5. Therefore 15 divided by 5, 1. This would be double counted. All of this set theory, basically using the set theory. That's what you are trying to say there. Fair enough. This is another way of looking at this particular stuff. This is another way of looking at this particular stuff. Fair enough. So if you are doing that, you look at this 27, 21 and you say that, hey, the multiples of 3 should be discarded, multiples of 7 should be discarded, and I need to add back the multiple of 3 as well as 7. How many multiples of 3s are there up to 21? 7. How many multiples of 7 are there up to 21? 3. Okay, how many multiples of 3 and 7 are there? 1. Therefore, what I do, I will add 7 into 3, which becomes 10. I will subtract this one because it will be double counted, because this 21 is a part of this also, this 21 is a part of this also. Therefore, I am subtracting. Therefore, I am adding it back because it is subtracted twice. I am adding it back 11. Okay. Out of 21 numbers, what is that you are trying to say? Out of these 21, so you have to subtract because it's a double counted, right? Out of 21 numbers, 9 numbers are not in your favor. So therefore, you are saying that how many numbers? None of these. I want none region. How many numbers are in your favor out of these 21 numbers? Therefore, you say that number of numbers are out of 21 numbers, 9 are not in my favor. Therefore, remaining 12 are in my favor. Okay, cool. All right. So look at the second thing, my friends. Now look at the second thing I'm trying to make here. Point number one. So either this is very rudimentary, elementary way to explain this. This is a little better set theory kind of thing to explain this. Okay. Now the third point. All right, let's come to the third one. So even before we do that, let's understand one more pattern between this. Before I remove these numbers, let's understand one more pattern, because this pattern is also important. A lot of questions are solved using this particular pattern here. What is the pattern? The pattern is this. There would be always, Euler's number is always even. Phi of n, listen to this very carefully. Euler's number for any number greater than 2, Euler's number for any number greater than 2, output is always even. Count. This is the count. The count has to be even. Don't give me odd number as an answer. Euler's number is always even whenever the number is greater than 2. Any number greater than 2, the Euler's number is even. Okay, what is phi of 15? See here, 8. Phi of 15 is 8. Hey, what is phi of 21? This was 12. What was phi of 21 here? The phi of 21 was 12. In the sense, 8 is an even number, 12 is an even number. The count is always an even number. Also in that even number, the first and the last, if you arrange the Euler's number in the order, the sum of the first and the last are going to be 15. The sum is going to be 15. Sum of the second and the second last will also be same. The sum of the third and the third last will also be 15. The sum of the middle numbers, whatever it is, you will always get the even number 8. 8 means what? 4 pairs are possible. There will be 4 pairs are possible. And each pair is going to be the number itself. What was the number here? 15. Therefore, each pair is going to be the number itself. That is the first, the last. You put them in the order, it adds up to the number. It adds up to the number. Sum of the second and the second last, that also adds up to the number. Third and the third last adds up to the number. Fourth, whatever the pairs are left there. If you put them in the ascending order or descending order, you make the pairs from the corners, first and the last, second and the second last, third and the third last, and so on and so forth. They always form the number. So I made I made 2 comments about this as well. First, we defined what is a Euler's number. Second, we understand that Euler's number is always even. Euler's number is always even as long as n is greater than 2. 2 is the only exception, 2 being only the exception. Point number 3, we also understood that when these even numbers are arranged either in the ascending order or in the descending order, they always add up to the number itself. Okay, now we understood so much. Now let's come back to this. Hey, is there a direct way to find out these none of these region? Is there any better way to figure out this none of region? Yes. All right, now look at this. Let me explain this 15. Let me take this case of 15. Listen carefully. Listen carefully. Compounding. You can use the compounding concepts to look at this as well. There are multiple ways to get into the. All right, there are multiple ways to deal with this. Okay, let me write this. Why you are writing 2 times? I will explain, because this is what finally we do. What I'm doing now, this nails down the concept. This nails down the concept. Okay, I want the Euler's number for 15. So 15, all right, we know that 15 means the number which is divisible by 3. I should remove all the numbers, all right, all the numbers which are multiples of 3, or discard all the discard. The word is discard. Discard all the numbers which are multiples of 5, which means what I need to discard here, I will discard the multiples of 3. 3 I'll remove every third number. 6 I would remove. I would remove 9. I would remove 12, and I would remove 15. Fair enough. That is what you did. Okay. Discard the multiples of 5. Discard the multiples of 5. From here I'm getting it. 5 I remove. 10 I remove. 15 I remove. Okay. So therefore, what is that you are left with? Listen to me. What is that you are left with? 1, because it is not discarded either in the first row or in the second row. 2, not discarded. 3, discarded. Either in the first or second, doesn't matter. Discarded. 4, not discarded. 5, been discarded. It is discarded down. Therefore, it is discarded. Overall, it is discarded. 6 is also discarded. 7, not discarded. 8, not discarded. 9 has been discarded on the top. Therefore, at the bottom also. 10 being discarded. 11, not discarded. 12, discarded. 13, not discarded. 14, not discarded. 15, discarded. Fair enough. How do I represent this mathematically? Therefore, listen to this. Every 2 out of third number, out of 3 numbers, what is the denominator? Listen to this. The multiple of 3 means out of every 3 numbers, 2 numbers would be selected. 2 numbers would be selected. These are the numbers. These 2 selected. These 2 selected. Only the first one. Go to the first row now. Just go to the first row and try to understand this. These 2 selected. These 2 selected, right? You are selecting these 2 numbers, right? Out of every 3 numbers, which means these are 3 numbers. Out of 3 numbers, 2 are selected. Out of these 3 numbers, 2 are selected. Out of 3 numbers, 2 are selected. You are trying to say that 2 out of 3 numbers are selected. out of 15 numbers, how many are selected? I will get to know. Okay, come to the second portion now. Come to the second portion. Okay, out of 5 numbers, now circled ones, I'll go only to the circled ones. How do you represent this particular thought on this? Out of every 5 numbers, 4 of them would be selected because one is discarded, circled one is discarded. Out of these 5 numbers, 4 are selected. Now you are saying that, hey, 4 out of 5 will be in my favor. 4 out of 5 are going to be selected. They would be in my favor. Therefore, out of 15, how much? But I want both. I want both. I want selections from the first row also. I want selections from the second row also. And the sample space is same. 15 is the same sample space. Therefore, compound them. Put them compound. Put them together. What do you mean? Hey, put this. 2 out of 3 are selected from the first row. And also and means into fundamental principle of counting, and 4 out of 5 are selected from the second row. All right, second row means multiples of 5. 4 out of 5 are selected from the second row. What is your sample size? 15 is my sample size. 5 3 times 15 gets cancelled. 4 into 2, how much? 8. This is what you precisely tried to tell me. All right, therefore this is what you precisely tried to tell me. 8 of these particular numbers are there. Okay, here you said that for 21, 12 of these numbers are there. Right, the 21 is nothing but a 3 and a 7. So if you look at 3, 2 out of 3 will be selected. Every third number is going to be rejected. 2 out of 3 would be selected. You look at this 7, 6 out of 7 would be selected because every seventh number is rejected. Therefore 6 out of 7 are selected. Out of 21, therefore what is the reason? Out of 21, so you say that a 3 7 I'll cancel, therefore 6 into 2, nothing but 12. Okay, did you get the reason very clear, everybody? Is it clear to you what we are trying to do? Is this reason clear what we did? You will not write the numbers, neither you write the Venn diagram. This is what you kind of write because this is the reason. Ultimately, this is the point. Point clear? Everybody point clear? Anybody confused? Let me know. Is the point clear here? Is this point clear what we are trying to do? We'll see what the applications are, how the questions will come. That's what we need to understand. This is fine. Nobody will ask you so directly. Find the Euler's number for 21. Nobody ever going to ask that question. Nobody ever asked this question. Right? Yeah, but then how do we apply this? Knowing the concept is what we need to check. We need to check that. Okay, good. All right. So generic way. All right. 11th standard mathematics book will have this formula. Right. So, okay. So generic way, if the number can be represented as any composite number n, if any composite number n can be written as prime 1 raised to power a, prime 2 raised to power b, and prime 3 raised to power c. Powers can be different as well. Powers need not be 1 every time. The powers can be different as well. In that case, the phi of n can be written as, it's always a function of prime. It is independent of the power. It is always a function of prime. It is nothing to do with how many times you have taken that particular prime. It is nothing to do with that, right? So therefore, it's always a function of prime. You will write prime 1. You will say that n prime 1 minus 1 divided by prime 1, because every prime number, which means every third number, if you look at 3 here, every third number is discarded, which means the remaining numbers are selected. P1 minus 1 divided by P1. You look at this and then you will write this as P2 minus 1, whatever is the prime number. If it is 7, 7 minus 1, 6 of them will be in your favor. That's what you are trying to say. P2 minus 1 divided by P2. What if I have another prime number P3, for example 11? This P3 value was 11. Fine. So 10 of them would be in your favor out of 11. That is P3 minus 1 divided by P3. What is that? Why you are writing this minus 1? One number out of P3 numbers would be discarded. Rest will be in my favor. Okay, what was your sample space? My sample space was n. Multiply this by n. You get the number of numbers co-prime to given number which are less than or equal to n. Okay, this is the point. This is the summary. Whatever I tried to discuss here, this is the summary of that particular story. What is this P minus 1 that we wrote? I said that P minus 1 will be in my favor out of P1 primes. P2 minus 1 numbers will be in my favor, except 1. All of them will be in my favor. That favorable is what I wrote in the numerator. Multiply this by n. Multiply this particular number by n. You will find all the numbers which are co-prime to the given number. Okay, let's keep this in mind. Now let's open up to the questions. Let's see that, okay, how the questions will come. Okay, any doubts at this point in time, everybody? We'll straight away open up to the CAT questions. We'll do some of the, because CAT questions are simple on this. It is not Euler's theorem, it is a Euler's number, right? That's halfway to Euler's theorem. It's kind of halfway to Euler's theorem. Let's understand how do we go about this, therefore. Okay, right, very good, very good. Therefore, some people use Venn diagram to solve this question. Some people don't use Venn diagram to solve this question. Those who understood the way we have to look at it, 2 out of 3, 6 out of 7, like this compounding, those who understood the concept, they don't use it. Already, yeah, let's see how the questions will look like. How the questions will look like. This was the CAT question as it is. This was the CAT question even before you guys were born, I guess. This was before 2000. One of the CAT questions. Long time back, this was one of the CAT questions. This was one of the CAT questions which has to be done. Now listen to me very, very carefully on this question. Listen to me. The number of positive integers not greater than 100. All right, number of positive integers not greater than 100 which are not divisible by. It should not be divisible by 2. It should not be divisible by 3. It should not be divisible by 5. Technically, what is the meaning of this? Hey, if you are looking at this, take these 100 numbers. You have a divisibility by 2, divisibility by 3, and divisibility by 5. You have these numbers. Okay, but this is not the approach. This is not the approach. I'm just explaining what is this question about. Okay, you have all the numbers from 1 to 100, 1, 2, 3, up to 100. You remove all the numbers which are divisible by 2, remove all the numbers divisible by 3, remove all the numbers divisible by 5. Whatever comes in the none of these is going to be your answer. This is what you have to find out. How many numbers are there in the none? We already did this. Okay, fair enough. Take a multiple of these numbers, multiply them, simply multiply these particular numbers, call that as the sample size. You may say that, sir, sample size is 100 already given, but we can't work with their sample size. Just like our Fermat's theorem, when we had this number 2 raised to power 100 when divided by, say, when divided by 19, what is the remainder? We looked at this number 100. We said that I know, man, 2 raised to power 18 when divided by 19, the remainder is 1. From there we work pretty similar to that. I am doing it here. You gave up to 100. I am not worried about that 100. I am worried about what concept I know. I will simply take the multiples of this. There is a 2, there is a 3, there is a 5. Multiply them. This is my sample size. 2 into 3 into 5. 2 into 3 into 5, meaning all right, now this is nothing, all right, now this is nothing but 30. Out of every 30 numbers, let's say that I divided my 100 numbers into 1 to 30. I will make the batches of 30, 1 to 30, then 31 to 60, all right, then 61 to 90. So because whatever the study we do from 1 to 30, it will be same in the next bunch of 30, it would be same in the next bunch of 9, in the next bunch of 30, and then I'll be doing it then from here I will be doing it 91 to 100. I will do it manually from 91 to 100, right? Okay, let's understand when I'm looking at this from 1 to 30, what is that I'm trying to do here? I'll find the Euler's number for 30. What is Euler's number for 30? 1 by 2. You look at this 2, you write it as 1 by 2. You look at this 3, you write it as 2 by 3. You write it as 2 by 3. You look at this 5 and you will write this as 4 by 5. Fair enough, leave all this. All right, now you write it as 4 by 5. How many times? 30 times. Because you are writing 5 of 30. 5 of 30, which means in a sample size of 30 consecutive numbers. This is the truth. Okay, you multiply them. 4 into 2 is 8. Okay, so which means Euler's number for this is 8. Next 30 numbers, because this is a set of another 30 numbers, it would be 8. Set of next 30 numbers, this also would be 8. 8, 8, and 8. Now I just have to find out manually how many numbers are there between 91 and 100. Fair enough, I will write 91, 92. This is manually, I will do 93, 94, 95, 96, 97, 98, 99, and 100. Fair enough. Every third number, every second number has to be going. 2 gone, 94 gone, 96 gone, 98 gone, sorry, 98 gone, and 100 gone. Hey, why these numbers are gone? They are divisible by 2. Fair enough. The numbers divisible by 3 also should go away. All right. Therefore, 93 gone, 96 gone, 96 was already gone. Mark it once again, doesn't matter. 99 gone. Okay. Numbers divisible by 5 also should go away. Numbers divisible by 5 also should go away. Okay, therefore 95 gone and 100 gone. Okay, what is left? Therefore 91 is left and 97 is left. Only 2 more numbers are left. Therefore you say that, hey, in this range 2 more would be counted. 8 plus 8 plus 8 plus 2. Right? Therefore you are saying that your answer is nothing but 26. Did you all understand this concept? Is this clear to you? Concept is clear, everybody? Concept is clear. That is how you kind of approach. You go somewhere closer to this 100. You look at 100, don't worry. You look at these values, go close to 100. Rest of it handle manually. Rest of it can be handled manually. Right? Make the groups of 30. Every group of 30 will have the same number of coprimes. They have same number of coprimes. So you may not all know, because author may not give a number which is the multiple of these particular numbers. Author may not give. That's okay. We will handle that manually. We will handle that manually. Is this clear to you? Is this clear to you? Everybody clear on this? Everybody clear? Understood this question? Quick. Right. Good. Very good. All right. Guys, other than Aman and Prashant, Amar, Prashant and Mohit, others are also clear what we are talking? Did you understand the applications of whichever, whenever you get the set theory, you can use this. That's the point I'm trying to make. One of the application is wherever the set theory part comes, you can use this concept. Right? Yeah, that's a point there. Otherwise, knowing the Euler's number not applying doesn't make sense, right? Doesn't make sense. So when you know something, you also should know that how the questions would be presented on this. What are the multiple ways? There are about 4 applications. I will talk about 2 of them because the remaining 2 needs an understanding of the factors. So again, I don't want to digress from there. Yeah, this is another question. This is another question, cat question. This is another cat question. Try it. Everybody try it and give me the answer, my friends. This is another cat question. This is another cat question. We will do only cat questions. We'll take up cat examples because there are plenty of cat examples. Very similar, very similar. I expect the right answer from everyone now. Put the right answer to this question. Everybody solve. Put your head down, solve, and give me the answer. Yeah, it should take about a minute or minute and a half. Okay, guys, why so much time? It shouldn't take so much time. Anyway, I will extend by 30 seconds. I will count by myself. Give me the answer, everybody. Count it and give me the answer. It shouldn't take much time to count. You understood the concept. Apply it. Good. Hmm. Okay. Okay. Yeah. Right. All right. So what you do again, you take 2, 5, and 7. They're all primes. First of all, the divisible numbers should be primes. Please remember that. Okay. That should be primes. Otherwise, don't apply this concept. This is prime. What if it is not prime? We will figure out. We will figure out. Right. So first that should be clear. So divisible by 2, 5, 7. That should be prime. Otherwise, don't try to apply it or don't try to apply it kind of. Right. So you need to be little careful there. Okay. Yeah. Okay. So therefore I will take this multiple of these primes, 2 into 5 into 7. I will take these numbers. Fair enough. So you will take them, which becomes 70, which means in a bunch of 70 I can find out, but he said that I want up to 120 only. All right, so we can do it in 2 ways. I will take from 1 to 70, then 71 to 2 bunches, what to 71 to 140. Then I will come back and subtract between 121 and 140. I will come back and subtract this, right? That's easier. Rather than going forward 70 to 120 is too much of a journey. Rather than that, I will just come backward. I will come and I will subtract it, right? I will subtract it. That's much easier. I will see from which side to come. Which side to come depends upon what is the kind of a problem out here. That's all we are trying to do there. Okay, in a bunch of 70, how many do I get? We will find out. In a bunch of 70, 70 times of, you look at this 2, you look at this 2, 1 out of 2 would qualify. You look at this 5, 4 out of 5 would qualify. You look at this 7, 6 out of 7 would qualify. All right, so therefore you say that 70 is gone. You get 24 here and you get 24 here, but it is up to 140. When you got the 24, you counted up to 140, but you wanted only up to 120, which means what you don't want, I don't want from 121 to 140. Probably you can write it or you can count it manually. All even numbers will go because of the 2. All even numbers will go, all 5s will go like that. Already it doesn't matter how which way you want to do it. Okay, he says that 21 to 140. Technically, how many numbers, my friend? 20 numbers. Can I take the first 20 numbers? Yes. Right? Don't write 121 to 140. It is 20 numbers. Which 20? First 20 numbers of the next series. Therefore, you simply write 1 to 20. Even if you want to write it and do it, you want to do it faster. Write from 1 to 20. Don't write from 121 to 40. It is a set of first 20 numbers. That's it. All right, that is all the point here. So you write it as first and 20 numbers because it's easy to count. Let's say I'm showing it completely. You can do it mentally as well. 16, 17, all of this, 17, 18, 19, and 20. Point is what? Hey, these 20 numbers, the 20 numbers is the symbolic of the first 20 numbers itself. No big deal about it. Okay. Multiples of 2 I will remove now. First I will multiples of 2s I will remove. 2 gone, 2, 4, 6, 8. Okay. You don't have to write all of this to cancel. But nevertheless, all right, just to illustrate that I'm writing it here. Fair enough. Then all multiples of 5 should go. All right, 5, 10, 15 and 20. Fair enough. Okay, then all multiples of 7 should go. All multiples of 7 should go. 7 gone, 14 gone. All right, now, all right. So what are the numbers which are left now? Therefore, let me circle them. So what are the numbers that we are kind of left with? We are left with 1. We are left with 1, 3, right? Then third number, there is a fourth number, there is a fifth number, there is a sixth number, there is a seventh number. You said that, hey, 24 plus 24 and minus 7. You have 7 here, but what is that you are trying to do? Hey, this 24 is a positive sign. This 24 is a positive sign. This 7 is a negative sign because you didn't want numbers between this. Therefore, 48 minus 7, which becomes 41. Are you all learning something? Did it make sense? Clear to you? Did you all learn something? Is it making sense? This one application is you apply them when it comes to divisibility, etc. Instead of doing Venn diagrams, you kind of do this and kill this. Again, you don't have to write from 121 to 140. It is the symbolic of first 20 numbers. Just write first 20 numbers and count. That's faster because that can be done in your mind as well. First 20 numbers will happen faster rather than training your mind saying that from 121 you should do it. It will take time. 121 will take time. 1 to 20 takes very less time. So you should understand the concept basically. Clear about this? Everybody clear? Clear? Is everything clear to you? What I'm trying to say? Quickly confirm. Clear? Right. Why only 3 or 4 of you are able to answer? The others, it's becoming difficult. Others are still feeling it. These are very simple concepts. Honestly, these are level 1 questions. I am not telling this. This is what industry says. Industry means people in my fraternity says. All right, people in my fraternity, those who are looking at 99 and above percentile, honestly, these are all level 1 questions. I'm not kidding. You want to take up the good author's book and check out what is the level of difficulty of this question. They will place it as level 1. No, I want to make it tedious. Make it. That's a different issue. But then already we will not have time to get 99 percentile. Idea is if you want to get 99 percentile and above, your approach has to be clear, right? Otherwise, you will not get 99 because we all get 40 minutes. How do we solve many questions in 40 minutes? It's all because of approach. Concept should be clear and the application has to be clear, right? And then we have to practice something so that we gain the speed and momentum. These are the 3 things which are required there. Fair enough. All right. So let's go here. Let's go here. Another kind of question. Recognize this. Another kind of question. Another kind of question. Those who have a tryst with numbers, check this. Check this. This is also CAT question. Those who have the tryst with the numbers, check this. Based on the same concept, check how do we apply this there. What is the application? From where the application of, because already hint is there. I'm doing the application of concept that I have taught. So from where this application is coming, let's check it out. Who is this? Who logged in as army lover? Can I know the name? Nice fancy name. Yeah, it's good to like our army, no doubt. Which army you are talking about? What's your name? Can I know your name? Yeah, if you don't want to reveal, that's okay. Only if you think that okay, because name is something which is dear to people, right? Okay, Mr. Umesh, all right. Yeah. Yeah, listen, I will dilute this question. Listen, all of you, listen, let me dilute this question, then we will come back to this. Let me dilute. Had I asked something like this, listen, everybody listen, guys, everybody listen. Sum of 2 numbers. There is no order to it. I said that sum of two numbers. Let me write it when I'm saying it. Sum of two numbers is 96. 96. You may say that, sir, it is 360. I know that. I'm just writing it as 96 so that I can show, right? In fact, already I can show manually. I can show. I'll help you to visualize basically. Then where that Euler's number is coming, etc. We will be able to understand it. That's my point. A plus B is equal to 96. Let's say sum. Given that sum of two numbers is 96. There is no order. The A is different from B. Nothing like that. Sum, because of mathematics, when I have to write sum of two numbers is 96 means what? I have to write n1 plus n2 or A plus B, x plus y, whatever. Okay, then their HCF. HCF of the same two numbers is 4, let's say. HCF of the same two numbers is 4. Let's say that HCF of the same two numbers is 4. Okay, let's come back to this. Therefore, A can be written as 4x. A can be written as 4x. B can be written as 4y. You may say that, hey, why you can write it as 4x and 4y? Because if the HCF is 4, I can write it as 4x and 4y, right? 4x and 4y. It has become 96. That is what author is trying to say. If the HCF is 4, then A should be a multiple of 4. B also should be a multiple of 4. That is when I get the HCF of two numbers as 4. Alright, common sense. Okay. So therefore 4x plus 4y is equal to 96. From here you say that x plus y is equal to 96 divided by 4. 4 common. Fair enough. I'm reducing that number, that 96, I'm making it smaller. Okay, therefore this would now become 24. Now you are trying to say that, okay man, x plus y is equal to 20. Good. Now the point here is sum of two numbers is 24 means you can write 1 and 23. You can write 2 and 20 to 2 and 22. You can write 3 and 21. All right, you can write 4 and 20 like this. All right, you might have written finally 12 and 12. All right, and you will stop there. You may say that, hey, no need to reverse. Hey, can I write 13 and 11 here? Not required, because anyway he said two numbers. There is no ordered pair. He didn't write it as an equation x plus y, all of that. He said sum of two numbers is 96. Order does not matter. Okay, 12 and 12. 12 sample cases. But the point is, this is qualified. Listen very carefully. That is the concept. This is qualified. 1, 23 is qualified. This is disqualified. You may say that. Why this is disqualified? What is wrong with 2, 22 to be disqualified? Now you are saying x value is 2. Now what is A here? Go back to A here. A is equal to 4x. Okay. What is B? B is equal to 4y. Okay. So now you are saying that the value of x is how much? 2. Okay. Write it here. 4 into 2, which has become 8. Okay. So what is the value of corresponding value of y? 22. Therefore, you are saying that 4 into 22, which is equal to 88. Now you find out what is the HCF of 8 and 88. It is 8. Common sense. HCF of 8 and 88 is 8. But author said that, man, HCF is 4. Why on earth you are making it 8 now? So you don't have to make it 8. It has to be 4. Author said 4, but you made it 8 by writing this. Therefore, what is that you are trying to say? Now you are trying to say that x and y should be co-primed. That is where the word comes. That is where the word comes. You need to recognize something about Euler's number talks about co-primes. Euler's number talks about co-primes, but I should be mindful to understand in the exam that where is that word co-prime coming there. Now this is where the word co-prime coming. X and y should be co-primes to each other. Is 1 and 23 co-prime? Yes. Or 2 and 22 co-prime? No, because the HCF is 2. Because the HCF was 2, now already HCF 4 was taken out. The HCF 4 was taken out, and you are adding another HCF 2 to this. Therefore, 4 into 2 has become 8 there. So which means what I need to select? I need to select the numbers which are co-primes to each other. That's what I need to be selecting. I can't select this. I can't select 3 and 21 also because the HCF is 3. I need to be selecting co-prime numbers. Okay, fine. If you need to select co-prime numbers means what? You will at least reduce the sample size, something like this. Remove all even numbers, because when you write 222 even, right? When you write 4, call it 420, call it 4 plus 20 is 24 even. Remove even numbers, write only odd numbers to start with. 1, 3, 5, 7, 9, 11. Sum 11 plus 13, 15, 17, 19, 21. Put them in the reverse order. What I'm trying to say, 1 plus 23 is 24, 3 plus 21 is 24, and so on, right? That's what we are trying to say here. Okay, are these two co-primes? The first set is co-prime. Okay, is this co-prime? No, because the HCF is 3. Is this co-prime? Yes. Is this co-prime? Yes. Now, is this co-prime? No, because HCF is 3. Are these two co-prime? Yes, 4 numbers. Now, look at this. Even if you find out, alright, if you find out the number of numbers co-prime to 24 and less than 24, you get exactly same numbers. You get 1, you get 23, you get 5, you get 19. So, all these are co-primes. If I say that, hey, find the number of numbers co-prime to 24 and less than 24, you are precisely going to get the numbers which are alive. What are the numbers alive? 1 is alive, 23 is alive, 5 is alive, 19 is alive, 7 is alive, 19 is alive. And I also said that when you write this in the order, which means you write 1, 5, 7, 11, 13, 17, 19, and 23. Now these are the 8 numbers which are co-prime. The first and the last adds up to the number. Second and the second last adds up to the number. Third and the third last adds up to the number. The two middle numbers adds up to the number. That is what precisely you got them as the pairs. That is what you got them as the pairs. We learned the concept saying that, hey, if you write all the co-prime numbers in the order, the first and the last and the second last, they add up to the number. There is no point just knowing that, right? There is no point just knowing that. Idea is we need to be able to apply that, right? We also need to be able to apply to that. So now this is how you are applying. Therefore, what you would have done in this particular question, I would have taken this 24. I would have simply found out what is phi of 24. I will not write all of this. Fine. 24 was a small number. So I did that. What if it was, I just want, it was a large number there. If it is a large number, I will simply find phi of 24. What is 24? 24 is 2 raised to power 3 and 3 raised to power 1. What I need to look at? Only the base. I look at this base, I will write it as 1 by 2. 1 out of 2 numbers will qualify. I look at the base 3, 2 out of 3 numbers will qualify. Out of 24 numbers, how many would qualify? Fair enough, 2 cancel, 3 8 times. Therefore, phi of 24 is 8. 8 numbers qualify. How many pairs are there? 8 numbers are there. Like this, 8 numbers would be there in your series. But I want 2 at a time, x plus y, 2 at a time. If you want 2 at a time, 8 divided by 2, you will get 4 pairs. You will get 4 pairs. Okay, now did you understand the concept here saying that what we mean by saying that phi of n is even? Phi of n is even. The second one, first and the last, second and the second last, they add up to the number. So how the application CAT question comes? Are you able to visualize this? Are you able to visualize this? Did you get this point? Because knowing concept is one. The second one is you also need to know what are the applications of that. Right? What sometimes happens is people know the concept, but they won't be able to apply the concept because they don't visualize, they don't expose. You need to get that exposure. You need to get that exposure. Then you will be able to apply and get that momentum and speed. Then the question can, this is the level 1 question. This is a level 1 question. Euler's theorem at least becomes the level 2 question. But these are the level 1 questions what we are talking, because we are simply talking the application of Euler's number. We didn't even get into the theorem yet. Theorem we didn't do. Is it making sense, my friends? Everybody clear other than Aman, Prashant and Mohit? Others are clear what we are talking? Others clear what we are talking? Are you able to see the level 1 questions on CAT from numbers? Are you able to understand them? These are level 1, honestly. These are level 1. If you want to complicate it, can be complicated. But the idea is you need to know a little bit of math so that you can take advantage of it and solve it faster. That's the whole idea there. Okay, fair enough. Fair enough. All right, let's take a look at this. Let's take a look at this. See, that is where sometimes the IITians solve it very, very fast. Right? Why people, IITians, they don't need 40 minutes to do these 26 questions in Quant, right? 26 questions, 40 minutes. Honestly, not required. I've seen enough of them. So I've interacted with them. I know them. How do they do? Out of this 26 questions, they will know the answer to 22 or 23 questions. Let's say there are 2-3 questions which they also don't know. That's all right for them. So 22 to 23 questions they will know. They will finish this in about 35 minutes. Somewhere around 35 minutes. It can be 34, 36, whatever it is. They will have all this 5 minutes buffer time. They will have 5 minutes buffer time because their abilities are much more than what is being tested. That's what happens there. And therefore they will get, because they don't know those 2-3 questions. Between this 22, 23 questions also they may get 1 or 2 wrong. All that stuff. Therefore, they end up getting somewhere in the upward of 99+%. Reason, when did they do all of this? All of this they would have done in their 11th standard. Hall and Knight. Every IITian would have solved the book called Hall and Knight. Right? Higher Algebra by Hall and Knight. They would have solved it. Higher Algebra. Right? Yeah. Higher Algebra by Hall and Knight. I'm sure everybody who has done the sciences in a good way, trying to qualify, we all would have solved the Higher Algebra by Hall and Knight, and maybe many more after that. Adi Sharma, this, that, all of that. But definitely Hall and Knight would have been one of the reference books. Like that, many other reference books also. But this is very, very popular in IIT circles, I guess. So all these questions, you give it an IITian, he will laugh at this. What is this kind of question? All right, because they would have solved into 4 times of this question. This is nothing, honestly speaking. See, therefore, idea is what we also have to know this. That's my point, what I'm trying to say, because I'm just putting forth my experience with those kids, right? How they appear this particular CAT paper, etc. Knowing them, I'm just trying to put forth saying that, hey, these are honestly level 1 questions, because you got to fight with those IITians as well who are writing. For them, these are already level 1 kind of questions. We also need to treat it like that only. We cannot complicate it by saying the tough man, level 2, level 3 kind of. No, stupidity. Okay, let's come back to this. Let's come back to the discussion. Sum of two numbers, a plus b. A plus b is equal to 360. Sum of two natural numbers, 360. First number can be written as 4x. Second number can be written as 4y, which is equal to 360. Fair enough. So therefore, you would say that x plus y is equal to 360 divided by 4. This is all you would have done, which would become 120. Sorry, which would become 90. All right, which would become 90. Fair enough. Go to 90, find phi of 90. What is 90 first of all? What is this 90? 90 is nothing but 3 square, 2 power 1 into 5 power 1. This is my 90. All right. So I am now writing phi of 90. What is phi of 90? I look at the base 3. So therefore 2 out of 3 numbers qualify. I look at this base 2, 1 out of 2 numbers qualify. I look at this base 5, 4 out of 5 numbers should qualify. Into what? Sample size. Sample size is this 90. I will write it as 90. Fair enough. 9 2 times 10, 10 2 times 30, therefore 33 times. I will multiply them. 2 4 times 8, 8 3 times, or 2 4 times 8 3 times 24. Therefore, you say that phi of 90 is 24. There are 24 numbers. When you write them, there will be 24 numbers, but I want pairs because I want one here and one here, one here and one here. I will not get 24. So therefore, number of pairs will be 24 divided by 2. Answer would be simply 12. This is how you kind of approach this particular question. Fair enough. Did it make sense, my friend? Everybody clear about this? Everybody clear about this? All clear? Aman, what is that 48, man? Where you got that 48, buddy? 12 is the answer. 12 pairs. You will have 12 pairs. 12 pairs. What is that 48 you have written there? Is it by mistake you typed something? Is it clear or is there a confusion? You got some 48. What is that? If you tell, I will try to rectify that, or it was just a confusion that because of which you wrote. Aman? Clear, right? Okay. Good. 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 Yeah, all right. So this looks pretty much a time. So what I'll do is Euler's theorem I will take up in the next lecture. I wanted to finish this today, but somehow already this explanation of the concept took a lot of time. So I am a little disappointed that we could not do too many questions today. Yes, but then we will take up the Euler's theorem in the next lecture. I wanted to finish the theorem today, but then now if I start, it will take another 40-45 minutes. Right? Somewhere I factored the time wrong. I don't know where the time went today. So we also started about 5 minutes late, I guess. All that would have factored in. So theorem, I will do it in the next lecture. I will do it in the next lecture. Quickly, I'll let know a couple of things before you kind of get out there. So if you like what the content that we are talking, so you can also, there is another lecture coming up, that's tomorrow, 10:30. If you are struggling in VRC, if you are not struggling, don't worry, right? Yeah. So if you are struggling in VRC, then already you can attend this particular 30 minutes briefing or 25 minutes briefing. I'll keep it pretty short and pretty to the point. You can attend that, how you can actually improvise in the given time. You can improvise in the given time. Yes, and then tomorrow Venn diagrams will continue, the maximum minima, and at 10ish tomorrow night 10 we will discuss this, the second part of it, right? So Rahil, you were asking that. Aman, you were asking when will be the next lecture. The continuation lecture will be tomorrow night. Tomorrow night 10 p.m. we will do the Euler's number lecture. Okay, and if you're not, I'm doing the algebra module on the free special class. On the special class, I'm taking up the algebra module. So at around 6 p.m. in the evening, but on alternate days, something like 3 days I do that. Yeah, so you can, one next lecture is coming on 13th. So if you have not downloaded the app, please download the app, because you need to be doing this on the app where there is a less distraction. So you can download that particular app. While downloading, if it asks for a referral code, you can use this particular referral code there. Right? You can use that referral code. And if you have not liked the video yet, use this like button. So before you leave, in a sense, if you liked it, not liked it, don't bother about it. If you liked it, do that. Not liked it, don't worry. And you can also share it with some of your friends. Let them also watch, join in while we are trying to do this together. Yeah, so here are some of the new batches which are kind of getting launched. That is tomorrow. That's tomorrow, 11th September. So if you are preparing for 21 or 22, check if any of this kind of suits your requirement. Yeah, so now all of this, those batches, etc., can be joined, provided either you are taken the membership for Plus or you are taken the membership for Star. Star is nothing but iconic, one of these membership. So plus is more to do with the structured courses and the study material and the tests, all of this. The iconic gives you the interface for one-to-one. Guys, all it now said, doesn't matter whether you take here or there, you need to have one or two mentors to guide you, because if one person is busy, at least the other person is there for your timely needs. Ensure that there are always one or two people who have time for you, because you will have a lot of doubts coming up, anxiety coming up, right? So all of these things. So how do you improvise on the scores? It can be somebody wants to take a look at your test and try to suggest that this is one way you can improve your 10 marks, 15 marks out there. You might want to discuss your IIFT strategy or your ZAT strategy, whatever way it is, because your strategies can be little unique. What works for others need not work for you, because you could have been differently wired. In the sense, our strengths and weaknesses are different. We all can ace it, provided we kind of get the right kind of guidance, looking at your own strengths and weaknesses there. Right? So be it with respect to test, or be it with respect to, or be it with respect to your study planner. So how do I prepare for that? How do I prepare for this? Any of this. Not only that, especially the B school applications, right? So because if you're applying to the good B schools, everywhere you may have to write some responses to the dozen questions that they ask, and which are very, very important. Based on those dozen questions, a lot of questions are going to come in the interview, or a lot of interpretations are done. Even if it is not asked in the interview, by reading that, they will give some points there, which becomes kind of important. Those questions are pretty important, and this has to be done in consultation with some. Always, once you write, show it to somebody who can actually kind of reads through it and comments about it, right, wrong, ugly, good, bad, whatever it is, and they will give some critical comments about it, so that you can improvise your writing, so writing of your responses, etc. Yeah, that is what iconic technically does. In the sense, you can set up one-to-one meetings. So if I were you, so one thing that I kind of prefer could be a little bit of iconic side. That's what is required in the last mile. Last mile, that is what can help technically. Yeah, plus subscription, CAT 21, 22, 23, respectively. These are the packages that they have come out with. And on all these prices, whatever is mentioned, you will get a 10% discount. If you use any user code, if you are following me, you can use my user code as well. Yeah, iconic subscription, as I told you, this is the most preferred if you are looking for CAT 21. So you should kind of try this particular preference. Might make some sense. According to me, that would make some lot of sense going in there, so that you will maximize your chances of putting the right application, right college, right presentations, etc. Fair enough. That brings me to the end of this particular discussion. Any questions? Present me there. Post it. Post it if you have any questions. I will answer some of them if there is something to be presented. Yeah. Nothing, then we will wind up. If there is nothing, good night, Mr. Prashant. Good night. Good night. Sleep well. So I will see you morning at 10:30. I'll see you guys about 10:30 in the morning. Yeah, any questions? No questions? Then I will close the meeting. I will close the meeting if there is nothing. Okay, all right. Then eat well, sleep well. I will see you guys at 10:30 in the morning. Bye till then. Good night.